let's go through this one more time. I have an airplane at the top of a cone, and it's flying at some altitude h, which is not shown. And he's flying no wind at a bank angle phi. And if we have a no wind situation, airspeed and ground speed are the same with our relative position vector from the earth frame. If we sum forces down and define lift correctly, we'll get the number of g's is only a function of the bank angle. Only a function of the bank angle. I've said this about 20 times, so what does that mean about exam 1? This is going to be on exam 1, right? Right. Both of these are going to be on exam 1, I'll tell you that right now. G's are only a function of the bank angle. Then you'll get lift sine phi is mass times centrifugal acceleration, and after some manipulation you get that the radius of turn, which is our performance metric, is v true airspeed squared over the tangent of the bank angle times gravity in the denominator. Now here's what I want you to do. I want you to show that a better formula for radius of turn is given by the following. A better formula, this is the one that's actually used, comes right from the tangent. Radius of turn is equal to Vt squared over g times the square root of load factor minus 1. Okay? I want you to show this. I want you to drive that. So try to do it for tonight. I'm going to give you a hint. All right, the hint is that the sine squared of phi plus the cosine squared of phi equals 1. Now you knew that, but that's the hint. So don't spend a lot of time on it, but see if you can manipulate this formula here, which is not very practical, to the one that's continually used. That shows you the more g's you pull, the less the radius of turn. So this is a fundamental formula that we use. The second thing I'd like you to show for tonight, or I guess you should turn it in with your quiz, huh? Turn this in with your quiz for another 5%. So this will give you another 5%. Do this, and tell me what height you have to be at, h. So, you know, we have this distance here. What height do you have to be at above the ground so that at this bank angle I'm pointing to the center of the cone? Okay. I could have been at any bank angle, but my bank angle points to the center of the. In other words, I'm making a turn about a point on the ground. If I'm flying an airplane, my bank angle, my wingtip, I'm looking at a whale right there. And I'm flying at a whale. I'm flying right around a whale. Now, normally to do that, I have to go up and down. It's called pivot turning pivot. But if I was at just the right height, I wouldn't have to go up and down. With no wind, I could just fly like this, and I keep this wing pointed right at that whale. What height would that be, given the parameters of this? Little geometry problem.